This training module will introduce you to the basic principles of pressure. Pressure or differential pressure measurement in a process or plant can be used as direct measurement to detect the pressure in a pipe or, for example, the differential pressure between input and output of a filter, but also in a lot of applications for the measurement of some other variables. These are flow rate in a pipe, level of fluid in a tank, density of fluid or interface level of two fluids in a tank. For density of fluid and interface level, a differential pressure transmitter is always necessary, very often combined with diaphragm seals. The preceding method leads to density measurement in a tank. In this case, a homogeneous liquid of changing density in the tank will exert varying pressure on the transmitter depending on the change in density. This measure can be applied either in open or closed tanks and with clean or dirty fluids. As long as the level remains above the top tap, and as long as H is constant, the transmitter will respond to changes in density. Density is weight per unit volume. For example, kilograms per cubic meters or pounds per cubic feet. If the density increases, the pressure on the lower tap increases, and so does the transmitter output. Typically, as in level measurement, a differential pressure transmitter is used, because the difference between top tap and bottom tap has to be measured. To calculate the range to which the transmitter should be adjusted, the distance between the lower and the upper tap, called H1 in the drawing, must be known. Because the measurement is performed by a transmitter with diaphragm seals, the specific gravity of the filling liquid in the capillaries must be taken into consideration, in addition to the fluid in the tank. Therefore, the specific gravity of the diaphragm seals filling liquid must be known, and of course, the specific gravity of the process liquid. The dP range calculation is the following. Lower range value, LRV, equals height, H1, multiplied by minimal specific gravity of process liquid, SGPL, minus specific gravity of liquid in capillary, SGC. Upper range value equals lower range value plus height H1 multiplied by maximal specific gravity of process liquid, SGPH, minus minimal specific gravity of process liquid, SGPL. Interface level measurement is measuring the position of an interface between two separated liquids, such as oil and water. It can be applied either in open or closed tanks or with clean or dirty fluids. It is measured using a differential pressure transmitter. Liquids 1 and 2 are of different densities, and as long as the total level in the tank is above the top tap, and as long as the distance H remains constant, the change in density, and hence the hydrostatic pressure, will change with interface level change. Very important notice. Total liquid level must always be above the top transmitter tap. Both the densities must be predetermined and should remain constant for accurate measurement. To calculate the range to which the transmitter should be adjusted, the distance between the lower and the upper tap, called H1 in the drawing, must be known. Because the measurement is performed by a transmitter with diaphragm seals, the specific gravity of the filling liquid in the capillaries must be taken into consideration, in addition to the fluid in the tank. Therefore, the specific gravity of the diaphragm seals filling liquid must be known. In this case, the interface position is to be measured. Therefore, for the range calculation, you must know the specific gravity of both of the liquids in the tank. The dP range calculation is the following. Lower range value, LRV, equals height, H1, multiplied by lower specific gravity, SG1, minus specific gravity of liquid in capillary, SGC. Upper range value, URV, equals lower range value plus height h1 multiplied by higher specific gravity Sg2 minus specific gravity of liquid in capillary Sgc.